Hello, dear student. How are you? I hope you are doing good. So once again, we are here with the AIT 7 NEET Physics question paper discussion. So as usually, we have selected some problem based on the difficulty level of the examination, and we are going to solve them one by one and see the concept behind it. Okay. So move on to the very first question is a wire suspended vertically from one of its ends. It's stressed by attaching a block of mass 200 kg to the lower end. The weight stretches the wire by 1 mm. Then the elastic energy stored in the wire is. Now, it's very simple to find out just to apply the right concept here. Now we have a wire by the lower end of it is connected with a 200 kg block, which obviously causing stretching by applying a force which is mg, or you can say 200 times g, and this is the weight of the block. This will cause the tension in the string, and this tension cause the stretching in this wire. So this stretched delta L, which is change in length, is given to you 1 mm. Okay, the mass is given to you 200 kilogram. Now finally we have to find out elastic potential energy, or I will say elastic energy. Elastic energy. Now we know the expression of elastic energy. It is 1 by 2 times stress into strain into volume. Okay. Now we can write, we need to do some modification because only the weight, which is kind of force acting on the wire, and the change in length of wire is given. So we need to make some modification in this. So stress ko we can write force upon area. Strain we can write change in length over original length. And volume, because this wire is cylindrical type, so we can say that volume of this wire will be area into length. So it will be written as A into small l. Now small l, small l, capital N, capital A will cancel out. The only thing you left with 1 by 2 F into delta L. Now you know the force which is acting on this wire is this 200 kg block weight. So we can write it as mg, which is 200 into 10, the value of g. The value of delta is given as 1 mm, so we need to convert it into meter. Now this will result out as 1 joule. So this is the elastic energy stored in this. Now move on to the next one. The moment of inertia of disk of mass capital M and radius r about an axis which is tangential to the circumference of the disk and parallel to its diameter is. Now to solve these kind of problem, we first make the diagram of the situation. Now we have this disk with center this. This is the center. We need to find out the moment of inertia about this axis, which is parallel to the diameter and tangential to the circumference. So we can assume this as the desired axis that about which we need to calculate the moment of inertia. Now, to find the moment of inertia about this axis, let's say this axis is axis A. We need to know the moment of inertia about this axis. Okay. Now we know that this is a symmetrical body. So about this axis and this axis, the moment of inertia will be same. And this is the perpendicular axis. This axis is the perpendicular axis. Let's say we consider this axis to be x, this axis to be y, so this axis to be z. We can say that according to perpendicular axis theorem. Perpendicular axis theorem. So according to perpendicular axis theorem, Iz is given by Ix plus Iy. Now, we know that Ix and Iy are same because of the symmetricity. So we can say that it is 2 times of I into Iz. Now, Iz ke about we know the moment of inertia of disk. It is 1 by 2 times mr square because this is the center of this disk. So the moment of inertia about center is half mr square. If the radius is r, which is also given to you, and mass is capital M, which is also given to you. 2 times of I. So I will become 1 by 4 times mr square. Now if you apply parallel axis theorem. So parallel axis theorem says that moment of inertia about non-axis, unknown axis, let's say IA, will be equals to moment of inertia about non-axis, which is we will consider x, plus mass of the body and the distance between two axes, which is obviously capital R with the radius square. So IA will be 1 by 4 mr square plus mr square. So IA will be 5 by 4 mr square. This is the correct one. Option A is the correct answer. Now move on to the next one. This one. A uniform disk, again disk is here, of mass capital M and radius capital R, is mounted on an axle supported in frictionless bearing. A light cord is wrapped around the rim of the disk and a steady downward pull T is exerted on the cord. Now the angular acceleration of the disk is. So this is the disk which is joined on this axle. The rim we take the outer periphery of the disk. This rim is connected to a cord which is pulled by a tension T, or you can say a downward pull, capital T is applied on the circumference of this disk with the help of the cord. Okay. Now the angular acceleration is being asked. You know that this disk is rotate about the center axis, which is connected to the axle. Okay. So we know that if I apply torque is equals to I alpha, where alpha is the angular acceleration. This is the equation for finding out the angular acceleration. This is equation 1. Now, torque we have, torque is caused by only this pull, okay, which is apply on the cord. It is given by, torque is always given by, we know that torque is, if I talk about the magnitude, it is Fr sine of theta, or you can say that F multiply with R perpendicular, which is perpendicular distance to the force. So force here is T, perpendicular distance will be because from the center of rotation. From the center of rotation, this would be the perpendicular distance, which is the radius of the disk. So we can say that it is T into R. I about center we have seen in the previous question. About center it is mr square into alpha. Now R and R will cancel out. So alpha will become 2T upon M into R. This is the angular acceleration. Look how simple is this question. So option C is the correct one. Now, a man of 50 kg mass is standing in a gravity-free space at a height of 10 meters above the floor. He throws a stone of 0.5 kg mass downward with a speed of 2 meter per second. When the stone reaches the floor, the distance of the man above the floor will be. So that we have to calculate. Now, if I talk about this is the man here, he has a stone in his hand, and let's say this is a floor about 10-meter high. It is standing, he is standing on the in a gravity free space. So if there is no gravity, there is no external force. So initially the center of mass of this stone and this man will be at the same position. We know that. Okay. And when it releases this stone, it will reach down to the ground. Okay. And the stone has a weight of 0.5 kg. And man has a weight of 50 kg or mass, you can say. So when the stone reaches the ground, how much distance this man would cover, that we need to calculate. Now, and it has thrown it with a speed of 2 meter per second. Obviously, the distance covered by the stone from here is 10 meter only, because initially it is a 10-meter high. So concept here is, we must say that position of center of mass will not change in the absence of in the absence of any external force. Any external force. Because there is no gravity, so only gravitational pull can be act as the external force, but it is absent here because this space is gravity free. So there is no force, which means after throwing the stone, the center of mass will not change. So we can consider our axis system on this point also, x and y. So we can say that x is center of mass, or here we should calculate y center of mass, because in x direction it is not covering any kind of motion, it is not taking place here. So we will say that y center of mass will be m1 y1 plus m2 y2 divided by m1 plus m2. Now, if I consider initially the center of mass at this position, okay, for both man and stone, and this is origin, so it will be 0 0. So y center of mass will be 0 here. And if there is no external force, this center of mass will not shift. Okay, so this will become m1 y1 plus m2 y2. Now y1 we have taken for man. How much is goes up when it throw the stone to maintain the equilibrium of center of mass. So m1 is 50 for man, y1 is, let's say, y, plus m2 is 0.5 and y2 will be 10, because it is not going beyond the floor. So floor is at 10-meter high. So this will be minus 10 because it is going downward in the direction. Equals to 0. So 50y is equals to what? This will also become what? 50. Now 0.5 into 10 will become 5. So it will become 5. So y will be 5 upon 50, which is 0.1. Okay. So the man will travel above the floor will be initially it is at 10 and finally it has shifted. Y is the position of man. So this will be 10 plus y dash 0.1. So 10.1 is the actual position of man. So as stone goes 10 meter down, the man will go 0.1 meter up to maintain the equilibrium of the center of mass. Option B is the correct one. Now this one. So a solid material is supplied with heat at a constant rate. The temperature of material is changing with heat input as shown in figure. What does the slope dE represents? This. Now most of the student will confuse here because this type of curve they have seen between heat and temperature. But here the inverse is given. So what we will do, we will consider it as heat and temperature. We will just replace the axis. So what we will see, this is the solid. So solid temperature is rising up to point A. Now this is the boiling point of the solid, or we can say melting point. And from A to B, the solid is melting into liquid. So this is the phase transition. From B to C, again, now at B, the complete solid is melt into liquid. Now the temperature of liquid start rising at B to C, and at C, it is completely, it has the position in to convert the vapor. It has reached to its boiling point. Now from C to D, this liquid converted into vapor. Okay. And D, at D finally, all the liquid is converted into vapor. And from D to E, what will happen then? We are giving energy to vapor. Okay. We are giving energy to this vapor. So this will be nothing but the specific heat that we supply. If the heat is not changing the state, that state, and the heat is only changing the temperature of the substance, that heat is the specific heat capacity. Okay. Or heat capacity of the substance. So here the substance that we have at D is vapor. Now we have inverse this. Instead of temperature, we have put H, and instead of heat input, we put a temperature. Now we have to again inverse it. So here at D, we have got heat capacity as we have inverse the axis. So it will be 1 upon heat capacity. 1 upon heat capacity means inverse of the heat capacity of vapor. Okay. So option D is the correct one. So pay attention to the axis also. Okay. Now, some steam at 100 degrees Celsius is passed into 1.1 kg of water contained in a calorimeter of water equivalent 0.02 kilogram at 15 degrees Celsius, so that the temperature of the calorimeter and its contents rises to 80 degrees Celsius. Now, what is the mass of steam condensing? So this question, specifically this type of question, is the favorite question from calorimetry. Okay, from thermal properties of matter, there is a specific topic, calorimetry. The principle of calorimetry says that heat gain is always equals to heat loss. Okay, this is the principle of calorimetry that we are going to apply here. Now, there is some steam which is at 100 degrees Celsius has been passed into 1.1 kilogram of water directly, and 0.02 kilogram water equivalent. मतलब that substances you can consider 0.0 kilogram 0.02 kilogram as water. Okay. So whatever be the amount of that particular substance, you can consider it to be 0.02 kilogram of water equivalent. Okay. So that substance is equivalent to 0.02 kilogram of water. Now, if the steam at 100 degrees Celsius is passed into this amount of liquid, let's say water, which is at 15 degrees Celsius, so definitely there will be a transfer of heat. So we can say that let m amount of steam has been converted into liquid. It has been condensed into liquid. So this will be given by m into L. L is the latent heat. So latent heat, if it is not given, you will remember latent heat of vaporization is 540 calorie per gram. Okay. Now for calorie, because if you take L as in calorie per gram, so specific heat say you will take only one. That will be easy for calculation. If it is not mentioned, okay, then take this. So m into 540 plus when this steam, okay, this is heat loss. When this steam is converted into liquid, that liquid will also be the temperature of 100 degrees Celsius, because in phase change, there is no change in temperature. So that liquid, that water will again loses heat to this value finally, because finally it has reached to the 80 degrees Celsius. Now, so we can say that that same amount of mass mc delta T, and delta T will be the 100 minus 80 degrees Celsius. Okay, because the final temperature is 80, equals to how much amount of water we have to take? 1.1 plus zero point 0.02. That will also consider to be water equivalent into 1, and delta T temperature will be from 80 to 15. Final temperature is 80 minus initial temperature is 15 degrees Celsius. So this will become 560 m equals to 1.12 into 65. So mass here will be 1.1265 divided by 560. If you cancel this situation or sum of this, all this, so you will get 0.130, okay, in kg if you convert it into, okay. Now, so this one be the correct option, because this is also in kilogram, that is why. Now move on to the next one. In a thermodynamic process, fixed mass of gas is changed in such a manner that the gas release 20 joule of heat and 8 joule of work was done on the gas. If the initial internal energy of the gas was 30 joule, the final internal energy will be. Now this question is to just test your sign convention knowledge and the application of first law of thermodynamics. Solution, if I talk about, first law of thermodynamics says that the change in heat, or the heat supplied or heat released from the system, is always equals to the change in internal energy of the system plus work done on the system or by the system. So that we need to take care of the sign convention here in this question. Now, if you read it carefully, the gas release 20 joule of heat. So heat is rejected by the gas. In gas here we can consider our system. So heat is released by the system. So when heat is released by the system, it will consider negative. If heat is absorbed by the system, it will consider positive. So it is minus 20 delta U. You can write U final minus U initial plus here the work done on the gas. So if work is done on the gas, then it also taken as negative. If work is done by the gas, then it will taken as positive. So it is minus 8 joule. You can take this minus 8 here. So it will become minus 12. U final minus U initial is 30 joule. So U final you have as 18 joule. So finally the internal energy will become 18 joule. Okay. Now move on to the next one. This monatomic a monatomic gas at pressure P having a volume capital V expands isothermally to a volume 2V and adiabatically to a volume 16V. The final pressure of the gas is gamma is also given to you. So here we have two process. First is isothermal. Isothermal. So for isothermal we know that P is directly proportional to is or you can say that PV is equals to constant. Simple. Because temperature is constant. So we can say that P1 V1 is equals to P2 V2. Now the initial pressure is P, volume is V, PV, final pressure P2, final volume to 2V. Isothermally it is expand to volume 2V. So P2 you have as P by. Now second process here is adiabatic. Adiabatic. Now in adiabatic process, we know the equation of adiabatic process. PV raised to the power gamma is constant. So we can say that P1 V1 raised to the power gamma, P2 V2 raised to the power gamma. Now here P1 is not taken as P because here the pressure will be measured from P2. Okay. So P2 will act P1 here. So put the value of P2 here, it will be P by 2. Volume V1 will be V2 here because volume has expanded to 2V in isothermal. Then it expand to 16V. So V1 is initial volume is 2V for adiabatic. So 2V raised to the power 5 by 3. P2 you need to find out. V2 is 16V raised to the power 5 by 3. Now again open this, distribute the power. So you have P into 2 raised to the power minus 1, 2 raised to the power 5 by 3, V raised to the power 5 by 3. P2 16 raised to the power 5 by 3 into V raised to the power 5 by 3. You can cancel out this V. And finally, what do you have? P2 is equals to, if you take this, this will become 2 raised to the power 2 by 3. Minus 3 plus 5 will become 2. And divided by 2 raised to the power 20 by 3. Okay. So finally, P2 you have as 2 raised to the power P into, here we also have P. So 2 raised to the power minus 6, which is nothing but 64. So final pressure you have as P by 64. Option C is the correct. Now move on to the next. During the adiabatic change of ideal gas, the relation between the pressure and the density will be. Okay. So here the change in pressure and change in density has to relate. Now, very easy question if you know the equations. We know that for adiabatic process, we can say that P1 V1 raised to the power gamma equals to P2 V2 raised to the power gamma. Now we know that volume is nothing but mass upon density. Mass is something which is constant always. Mass is conserved. So if you replace this expression, we can say P1 into m upon d1, P2 into m upon d2. Now m raised to the power, if you distribute it further, P1 into m raised to the power gamma, d1 raised to the power minus gamma, P2 into m raised to the power gamma, d2 into d2 raised to the power minus gamma. This and this will cancel out. So we can say that P1 d1 raised to the power minus gamma, P2 d2 raised to the power minus gamma. So that is the relation between pressure and density in adiabatic process. So option C is the correct one. Now this question, a block of mass m is allowed to slide down a fixed smooth inclined plane of angle theta and length L. Now what is the magnitude of power developed by the gravitational force when the block reaches the bottom? So we can say, we will draw a figure here. Let's say this is the incline and block is here. This length is given as L. Initially it is at rest, finally it has acquired a velocity V. Okay, so we can say that this angle is theta. Now if we talk about the free body diagram of it, this will be mg weight. So if this angle is theta, so it will become mg cos theta, and this is mg sin theta. Now only this component of force will play a role in power, because we know that power is nothing but F vector dot V vector. V is the velocity here. So Fv cos of theta. Now, if we talk about this mg cos theta and the direction of velocity is this. So if we talk about this mg cos theta and this velocity, they have an angle of 90 degree. So cos 90 will become 0. So the power developed by this force is 0. Only this force, which is mg sin theta, will taken into consideration. Okay, because the angle between this mg sin theta and this v is 0. So we can apply here this mg sin theta into v into cos 0, which is 1. Now we need to find out this velocity. Since this force is mg sin theta, this should be equals to mass into acceleration, which is Newton's law of motion, second law of motion. So acceleration, you have a g sin theta, which is somehow constant. It is constant because g is constant and theta is constant. So g sin theta will be constant. So this is the uniform acceleration. We can apply the uniform acceleration equation. We know the length, we know the initial velocity. So we can calculate the final velocity by this expression. Now initial velocity is 0. So 2, because it is sliding down. No? So initially it is has a velocity 0. 2 into acceleration is g sine theta. S is L. The length is L. V square. Now V will be square root of 2 g L sine theta. If you put this value of V in this expression, what you get is power is equals to mg sine theta into root 2gl sine theta. If you take, because all the options are given in the square root form, and these are not valid answers because we are not getting that. So P is equals to, you need to take it inside, so you have to make the square of it and then take the square root. You can do it like this. Square root of mg sine theta square. So this will become m square 2 times m square L into g sine theta cube. Because g sine theta you have here, it is not square, it is only sine theta. So g sine theta you have here, g sine theta you will have here, but here we have g sine theta square, and here we have g sine theta, so it will become g sine theta cube. We have only L, power of L here 1 is, so L is 1 and m become m square. So this is the power developed, which is 2m square L g sine theta whole cube. Now this one, given that a shaped uniform wire of side 2L, L and L, the xy coordinate is also given, the center of mass of each side are shown in figure. The xy coordinate of the center of mass of wire are respectively. Now the origin is given here. From there, this is y-axis, this is x-axis. So it's very simple. R center of mass is given by x center of mass and y center of mass. This is the coordinate of center of mass. Now x center of mass you can easily calculate, m1 into x1 plus m2 into x2 divided by m1 plus m2, and y center of mass is given by m1 y1 plus m2 y2 divided by m1 plus m2. y1 and y2 are the center of mass of this system. y1 is the coordinate of center of mass on y-axis for this mass. For m2 mass, this is the coordinate of center of mass. Same goes for x-axis. Now, firstly, we will calculate it for x-axis. So for x-axis, it is m1. So here, this is for 2, but here we have 3 wires. This is 1, 2, and 3. So we can extend it to m3 x3 also plus m3 y3. Now m1 we will consider here this is 1, this is 2, and this is 3. Now m1, which is mass m, is given to you. x1, the coordinate is given to you. X coordinate of center of mass of this system is L by 2. L by 2 plus m2, this one, this is on the vertical axis, so it does not have any x coordinate, so you can put it 0, plus m3, this one has small mass m, this one, and coordinate of center of mass on x-axis is L by 2 divided by, this will also include m3, m1, m2, m3 ka sum. So m1 we have small m, m2 we have 2m, and m3 we have small m. So it will become 4m. Finally, we have ml over 4m, L by 4. This is X center of mass. Now Y, same goes for Y. So it will be equals to m1, which is small m, and again the coordinate of y-axis is 0 for it, so it will become 0 plus m2 into y2, this one. Now it has a coordinate on y-axis, center of mass individually of it, so it will be 2m mass of this wire multiplied by L, plus this wire also has, so it m into 2m divided by 4m total mass. So 2 ml into 2 ml will become 4 ml upon 4m. 4m will cancel out. This will become. So finally we need to put it here. X center of mass we have L by 4 and Y center of mass we have L. So option D is the correct one. Very simple. Move on to the next one. Two temperature scales A and B are related by A minus 12, A minus 42 by 110 equals to B minus 72 by 220. At which temperature two scales have the same reading? So what do you need to do? You need to put A is equals to B in these types of question. So you need to put A is equals to B. The solution of this question is for same reading, put A equals to B. So A equals to B, we only put A here. So A minus 42 divided by 10 equals to A minus 72, because we need to calculate the common temperature, 222. So this will cancel out two times. It will become 2A minus 84, A minus 72. So A will have you 12 degrees Celsius. Okay. Option C is the correct one. Now in this question, it has to mention that these scales measured in degrees Celsius. Okay. Now, the surface tension of a soap solution is 2 into 10 raised to the power minus 2 Newton per meter. To blow a bubble of radius 1 centimeter, the work done is. So very simple formula for these types of question. So work done is given by surface tension multiplied by change in area. This is the equation. So work done, we need to find out. Surface tension is given to you, 2 into 10 raised to the power minus 2 multiply by change in area is also given to you, because initially there is no bubble. Finally we have a bubble of radius 1 centimeter. So bubble is have a spherical shape. So spherical shape surface area is 4 pi r square. 2 into 10 raised to the power minus 2, 4 pi r square will be 1 into 10 raised to the power minus 4, because 1 centimeter square, so you need to convert it into meter square. So that is why 10 raised to the power minus 4 you need to multiply here. It will become 8 pi 10 raised to the power minus 6 joule. This is what. Option B is the correct one. An object is thrown towards the tower, which is at horizontal distance of 50 meter with an initial velocity of 10 meter per second and making an angle 30 degree with the horizontal. The object hits the tower at certain height the height from the bottom of the tower where the object hit the tower is. Now, let's say this is the baseline and this is the tower we have. Okay. And from here we have throw this stone or this object at 30 degrees Celsius, and the velocity of it will be 10 meter per second given. Now the separation between them is 50 meter. Okay. So let's say we can consider that at height h, this will strike the tower. Okay. So one information which is given in this question, that when it is hitting this tower at height h, it has covered a 50-meter distance. Okay. Now, we will need in this question Vx and Ux. So I will calculate it this U. So Ux is U cos 30, which is 10 by root 10 into root 3 by 2 meter per second. Uy is U sin 30, which is 5 meter per second. Now, in the horizontal direction, there is no acceleration, so we can directly apply this equation that Sx is equals to Ux into t. By applying this equation, we will calculate the time to reach at height h is same as the time to reach h 50 meter in horizontal direction. And that we will use in calculating the height. Now Sx is 50 meter. For the Ux, 10 root 3 by 2 multiply by time. So it will be 5, 5, 10. So t you have as 10 by root 3 second. Now Sy you need to calculate, which is given by Uy into t. We can apply the uniform circular or uniform accelerated motion equation. Uyt minus 1 by 2 Ayt square. Why minus? Because acceleration is downward direction, which is equals to gravity. So Uy, we will take U sin 30, which is 5. Time is 10 by root 3 minus 1 by 2, 10 into t square, which is 100 by 3. It's equals to 5. This will become 50. So if you take 50 by root 3 common, you have 1 minus 10 by meter. This will be the height at which this object will strike on this tower. Okay. The option is the correct one. We'll move on to the next one. Yeah. Firstly, we will see this question. So river 500 meter wide is flowing at a rate of 4 meter per second. A boat is sailing at a velocity of 10 meter per second with respect to water in the direction perpendicular to the river. Now the time taken by the boat to reach the opposite bank. Now let us consider this is the river we have. It has a width of 500 meter. Okay. Now the water is also flowing at a rate of 4 meter per second. And the boat is sailing at a velocity 10 meter per second with respect to water. So this is velocity of boat with respect to water is given to you as 10 meter per second. So with respect to boat, it is going in perpendicular direction. VBR is perpendicular. So how much time it will take? It has to cover a perpendicular distance of 500 meter. So time will be given by S by VBR. S is 500, VBR is 10. So 50 second it will take. Okay. This is the correct option. Now move on to the next one. Yeah. Two boys are standing at the ends A and B for ground, where AB is equals to capital A, sorry, small a. The boy at B starts running in the direction perpendicular to AB with velocity V1. Now the boy at A start running simultaneously with velocity V and catches the other boy in a time t. Now you need to calculate that time. The question is directly from relative motion. Now let us consider that this is B and this is A. Okay, so they has a distance between them as small a. Now at B, it has started moving in this direction with a velocity V1 and which is also perpendicular to this line AB. Now the boy A starts running simultaneously with velocity B to catch the and catches the other boy at time t. Now to catch this boy, which is already moving with velocity b, in time t, how much distance it will go? It will go around v1 into t in time t. And to catch this, it has to move in this direction. And in time t also, if it is catching this boy here, it has also cover v into t. Okay, got it? Now, if you apply the Pythagoras theorem here, which is, let's say this point is C. So Pythagoras theorem says that AC square equals to AB square plus BC square. Now AC square is V square T square. AB square is A square plus BC square is V1 square T square. Now you take this and this side, so it will become V square minus V1 square into T square equals to A square. So T square you have as A square upon V square minus V1 square. So time that you will get is A square upon V square minus V1 square. This is the time that it will take to catch the boy which is running from B. So next one, okay. So a uniform bar of length 2 meter and mass 3 kg is as shown in the figure. Now the tension at a point in the bar at 1 meter from the end is. Now I will solve it with a very basic method. Now you have seen that in the question there are unbalanced force acting on this. Here it is 6 Newton at this end and at this end it is 12 Newton. So there must be a net force on this uniform bar. So F net here you can say is 12 minus 6, which is 6 Newton and which is in the direction like this. Okay. So this force caused the acceleration in this object. So F net is equals to mass of the uniform bar into acceleration. So mass is given to you as 3 kg. F net is 6 Newton, 3 kg into acceleration. Acceleration you have as 2 meter per second square. Now, if you separate, because we need to find out the tension and there is no friction. So we have separated it from the given length. Okay. So the length of this is 2 meter. This is 1 meter. This is also 1 meter. Okay. Now here we have applied a 6 Newton force. Here let us assume the tension developed is C. So on the opposite face, tension is T, and here it is 12. Now each of this block is moving with the same acceleration because the rod is uniform here. So we can apply the Newton's law here. It will be T minus 6 is equals to mass of this block only into acceleration. Now you can easily say if the entire uniform or if the entire bar has mass of 3 kg, so exactly at the half portion, it has a mass of half also. So T minus 6 will be 1.5 kg into A. A is given to you as A we have already calculated is 2. So T will be 9 Newton. Option D is the correct one. Now move on to this one. Okay. Two trolleys of mass m and 3m are connected by a spring. Now they were compressed and released once. They move off in opposite direction and come to rest after covering distances s1 and s2 respectively. Assuming the coefficient of friction to be uniform, the ratio of distances s1 and s2 is okay. Now we know that if this is the surface, these are two trolleys which is connected by a spring. Okay, and they have mass m and 3m, let's say. And once they have been squeezed with this, so length of the spring will decrease. Then when we release it, the spring will apply the force on the system and they will move. So they will extend their length. Now we cannot say here that center of mass will remain constant because this surface has some friction. This surface has some friction coefficient. So whatever the elastic energy, whatever be the spring energy we have stored by the compression, it will convert it into the kinetic energy of these two trolleys. And we will move by this trolley. This trolley will move on the expanse of this kinetic energy. Okay. So we can say that if I apply the work energy theorem, so net work done is equals to change in kinetic energy. Okay. So work done here, if I talk about, work is done only by the friction because the friction will oppose the motion of these blocks. Got it? No. So work is done by friction, which is mg, mu mg into, let's say, the distance traveled by it is s1 and the distance traveled by it is s2. Okay, will be equals to 1 by 2 mv square. Got it? Now, if you focus on this s1, and this kinetic energy will be spend by doing work against this friction. Okay. So in this process, the work done that we will get against the friction here will be on the basis of the expense of this kinetic energy. Okay. So from here, if you relate these blocks, the motion of these blocks by the spring moment also, so you will find out finally what you will get, that the distance traveled by them is inversely proportional to the square of mass. Okay. So if you find out S1 by S2, it will be given by M2 by M1 whole square. M2, if you consider S1 to be this one for mass M, so it will be mass M, S2 will be, M2 will be 3M, and it will be M. Okay. Now, the square. M and M will cancel out. So S1 and S2 will be 9 by option D is the correct one. So I hope you have enjoyed. You will enjoy this session. This is it from my side. If you have any extra doubt in this, you can connect me in the regular classes. Thank you so much. Take care of yourself. Bye bye.